Today we are taking our MedInsights project to the next level. We will be improving our code structure for better maintainability and efficiency. More importantly, we will enhance our text-to-vector conversion process by replacing our current simplistic approach with more professional embedding model. Right now, we are using a basic function that converts text characters into normalized ordinal values. While it works, it's far from optimal for real-world AI applications. In this video, we will explore better embeddings models that provide richer, more meaningful vector representations. Let's dive in and make our applications more smarter and more efficient. First, we will start our virtual environment and the server. Starting the virtual environment, we need to run in MedInsights. Actually, we need to enter in our API, and then we need to run. We need to activate our virtual environment. Could not be loaded for more information. Okay, so we need to go back in this case and run, and yes, our virtual environment is activated, and then we need to go in our API, and then we need to run our server and activate our application. We have to wait a little bit, just a second. We don't need that. And a little bit longer. And yep, our application is running. And just a fast test we have to do. Probably just test and get. And yep, our application is working perfectly. One of the first steps we need to take is to create a new file called app.py and move the functions from main.py into it, leaving only the server startups logic in main.py. Separating the application logic from the server entry point is a well-established best practice in web development. In that way, we will improve a little bit our code organization and maintainability. Now, app.py handles the FastAPI application logic, while main.py is responsible only for starting the server. The next optimization we need to make is to improve the getAllRecords function. First, we will create a new function in repositories.py and move the existing code there. Next, we need to create a function in services.py that calls the fetchAllRecords function from repositories.py. and we need to import that function. After we finish with services.py, we need to call that function in app.py. And we need to import it. From services, we are importing getAllRecordService, the function that we just created. Actually, we are duplicating the importance from services. That's a little bit better. This refactoring that we did is part of the separation of concerns principle, which improve code organization, maintainability, and scalability. Each layer in our application now has a distinct responsibility. Repositories.py handles data access, fetching from the Qdrant. Services.py contains business logic, processing or handling exceptions. And app.py that defines the API endpoints and simply calls the service layer. Normally the endpoint should be in another file called controllers.py, but for our small application, for the moment, it's fine. The next important update we need to make is the creation of a class for customer handler. Let's paste the required code, and I'm doing it like that so I can speed up the videos. For you, if you are junior, probably it's better to type everything word by word, so you can understand it a little bit better. But in my case, I have to speed up the videos a little bit so that is faster, and we have to explain it. First, we need to import the necessary libraries and classes. Then we will create AppException class with the following two functions: exception handler and create. The AppException class provides a centralized way to handle exceptions across the entire FastAPI application. It ensures that errors are consistently formatted and returned as JSON responses. The class inherits from Python's built-in exception, meaning it behaves like a standard error. It is designed to handle errors uniformly throughout the application. Then we have init method constructor. This initializes an exception with message, the error message to be returned, and status code. The HTTP status code default is 500. That is internal server error. Next, exception handler. This asynchronous static method is the exception handler for AppException class. It returns a JSON response with the status code and content, that is dictionary with success false and error, the error message. And create method. This factoring method allows you to create an exception instance dynamically. We are using two decorators, static method and class method. Static method does not require access to self instance or the CLS, class itself. It belongs to the class but does not depend on the class attributes or methods. It behaves like a normal function inside the class, but is logically grouped under the class. If you don't use it, then it would require a self. Class method decorator. A class method takes CLS as the first parameter. Unlike a static method, it has access to the class and can modify or initiate it. It is often used for alternative constructor or factory methods. Create is a factory method that returns an instance of the class. It allows us to dynamically create an app exception without explicitly calling the constructor. For example, like this. And again, static method decorator is used for helper function inside a class that don't need self or CLS, the class itself. And the class method decorator is used when you need to work with the class itself, the CLS, especially for alternative constructors. And now how to use our custom error handler class. And we have to import it. It works. This line registers a custom exception handler for app exception, ensures that any instance of app exception raised within the application is handled in a consistent and structured way. It catches the exception and formats it into a consistent JSON response. Instead of returning FastAPI's default HTML error page, it returns a clean API response. What we are achieving here is centralized exception handling, no need to write try except in every route, consistent JSON responses, API consumers get structured error messages, cleaner, more maintainable code, less repetitive error handling logic, easier debugging, that's custom handler allow logging and detailed error tracking. Unfortunately, I didn't have enough time to complete all the tasks in this short around 10 minutes video, and I have to continue optimizing the code and use embedding models in the next video.